Okay, hello everyone. So for today we're going to talk about solving equations with a repeated variable. So this is the third part of my lecture about solving algebraic equations. So if you haven't watched the first two videos, you can access it by clicking the link on the description below. So for this video tutorial, you will learn how to apply collecting like terms in solving equations with a repeated variable, and also to identify the solution of the given equation. So before we begin, I want you to recall the following. Okay, let's start with like terms. So like terms are terms with exactly the same variable form. They have the same variables to the same power. So take note, same variable form, same powers. Okay. Suppose I have 3x and negative 2x. So 3x and negative 2x are like terms. So both terms contain the variable x. And the powers are also the same. Both x have power of 1. Okay? Next, we have negative 2y and 4y squared. Although the two terms contain the variable y, they are not like terms because in negative 2y, the power of y is 1, and in 4y squared, the power of y is 2. Okay, so since the powers are not the same, the two expressions are not like terms. Okay. Next thing is about collecting like terms. So collecting like terms is combining like terms to make one term by adding or subtracting the coefficients. So the coefficients are the number beside the variable. Okay. Suppose we have 3x and 5x. So 3x and 5x are like terms. So since the operation is plus, so what we will do is to add the coefficients. So the coefficients are 3 and 5. So 3 plus 5 is 8. And then copy the common variable. The common variable is x. So 3x plus 5x is 8x. So the second one. 5t squared minus 8t squared. So both terms are like terms since it contains the variable form t squared. Okay? So subtracting the coefficient, 5 minus 8 is negative 3. And then copy the common variable form, which is t squared. So 5t squared minus 8t squared is negative 3t squared. So the skill of collecting like terms will be very helpful later on when we talk about equations with a repeated variable. Okay? So in solving an equation with a repeated variable, we're going to follow the following steps. First, if necessary, expand out any brackets. So if there are any brackets in your equation, so what we will do is to expand it out first. Okay, so these brackets are also parentheses, okay, or braces, okay. Second, simplify each side of the equation by collecting like terms. Third, if necessary, remove the unknown from one side of the equation using inverse operations. Then the last one, solve the equation in the usual way. So when we say in the usual way, it's either solving a one-step equation or solving a two-step equation. Okay? Let's start with our first example. So in here you have 2d plus 3 parenthesis d minus 1 equals to 7. So there's a parenthesis or a bracket in this equation. So what we will do is to expand it out first. Okay? So to expand 3 parenthesis d minus 1, we're going to multiply 3 to d and 3 to negative 1. We call it distribution. Okay? So bring down 2d plus 3 times d is 3d. 3 times negative 1 is negative 3 equals to 7. Okay? So if you will look at the left-hand side of the equation, 2d and 3d are like terms. So we're going to combine them. So 2d plus 3d is 5d minus 3 equals to 7. Okay, so if you will notice that the resulting equation 5d minus 3 equals to 7 can be solved using two-step equations. So let's remove minus 3 first. So to remove minus 3, we will apply the inverse of it, okay, which is adding 3 on both sides. So negative 3 plus 3 is 0. So we can cancel this. So what will remain on the left-hand side is only 5d. And then simplify the right-hand side, 7 plus 3, which is 10. So we have 5d equals to 10. So to isolate d, okay, we want to isolate d, we're going to divide both sides of the equation by 5. Okay, so divide both sides of the equation by 5. So 5 over 5 is just 1, so we can cancel this. Okay, so the left-hand side will now be d, and the right-hand side, 10 divided by 5 is 2. So d equals to 2 is the solution. Okay, so let's proceed now with our next example. So in here, there's no brackets involved, but there are two unknowns. Okay, there are two unknowns on both sides of the equation. So what we will do is to remove the unknown from one side of the equation. Let's say I want to remove x on the right-hand side. So to remove x on the right-hand side, we're going to apply inverse operation. Okay? So the inverse of x is minus x. So I will subtract x on both sides of the equation. Okay. So to make it easier, I'm going to put all like terms beside each other. So 3x minus x plus 2 equals to x minus x plus 14. So I'm doing this so that it is easy for you to combine the like terms. So 3x minus x, okay, so 3x minus x are like terms. So 3 minus 1 is 2. So it becomes 2x plus 2. And x minus x is just 0. So we will just cancel this. And what will remain on the right-hand side is positive 14. Or we can simply write 14. Okay? So 2x plus 2 equals to 14 is a two-step equation. So we will start with removing plus 2. So to remove plus 2, applying the inverse of it, we subtract 2 on both sides. So 2 minus 2 will be cancelled out. So 2x will stay on the left-hand side. And 14 minus 2 is 12. Okay. So to isolate the unknown x, we will divide both sides of the equation by 2. So what we will have, okay, so 2 divided by 2 is just 1. So cancel this. So what will stay is only x. So x equals to 12 divided by 2, which is 6. So x equals to 6 is the solution. Okay? So again, if there are unknowns on both sides of the equation, what you will do is to remove the unknown from one side of the equation. So you may choose either you remove the unknown on the left side or on the right side of the equation. Okay? As long as you are applying the inverse operation and also maintaining the balance of the equation, it doesn't matter if you will remove the unknown from the right-hand side or from the left-hand side of the equation. Okay, so in our third example, we have 4x plus 3 equals to 23 minus x. So this is somewhat similar from our previous example. Let's say in this equation, I want to remove minus x on the left-hand side of the equation. So applying the inverse of minus x, which is plus x, I will add x on both sides of the equation to maintain the balance. So 4x plus 3 plus x equals to 23 minus x plus x. Okay, so I will write the like terms beside each other so that it will be easy for you to combine like terms. So 4x plus x is 5x. Bring down 3 equals 2. So minus x plus x is just 0. So cancel this. So what will stay on the right hand side is only 23. So 5x plus 3 equals to 23 can be solved by applying the steps in solving two-step equations. So we will remove plus 3 first. So the inverse of plus 3 is minus 3. So subtracting 3 on both sides of the equation gives you, so 3 minus 3 is just 0. Cancel this. So on the left hand side we'll have 5x only, and on the right hand side 23 minus 3 is just 20. So to isolate the unknown x, the variable x, we will divide both sides of the equation by 5. So 5 over 5 is just 1, so we'll just cancel this, and then 20 divided by 5 is 4. So x equals to 4. So x equals to 4 is our solution. Okay? Let's have our next example. So here we have 3 parentheses x plus 2 equals to x minus 1. So there's a bracket involved in our given equation. So we will expand it out first. So what we will do is to multiply x plus 2 by 3. So we will distribute 3. So 3 times x is, yes, 3x. And then 3 times 2 is 6. So positive 6 equals to x minus 1. So we have unknowns on both sides of the equation. So what we will do is either we remove 3x on the left hand side or remove x on the right hand side. Okay, but in my case, I want to remove x here on the right hand side. So to remove x on the right hand side, the inverse of it is minus x. So subtracting x on both sides gives you 3x plus 6 minus x equals to x minus 1 minus x. So I will write all like terms together. So 3x minus x plus 6 equals to x minus 1. Do not forget that when you are moving the terms, you need to carry on the sign. If it is positive, then make it plus. If it is negative, make it minus. Okay? So 3x minus x is just 2x. Bring down plus 6. X minus x is 0. So cancel this. So what will stay on the right hand side is only minus 1. Okay, so solving this equation using two-step equations, so we will remove plus 6 by subtracting both sides of the equation by 6. So 6 minus 6 will be cancelled. So what will stay on the left-hand side is only 2x. Then negative 1 minus 6 is negative 7. They are both negative, so we will combine them. Okay? So to isolate x, we divide both sides of the equation by 2. So 2x over 2 is just x, and negative 7 divided by 2 is negative 7 over 2, or we can write it as decimal x equals to negative 3.5. So this is the solution.